Assalamualaikum warahmatullahi wabarakatuh. The Honorable Vice Rector for Research, Innovation, Cooperation, and Public Communication of Universitas Diponegoro, Mr. Wijayanto, PhD.
Dear respected Vice Dean for Academic and Students Affairs, Faculty of Animal and Agriculture Sciences, Universitas Diponegoro, Dr. Heni Rizkyati, SPT MSI.
Vice Dean for Research, Faculty of Animal and Agricultural Sciences, Universitas Diponegoro, Profesor Agus Setiadi, PhD. Our honorable speakers, Profesor Didi Wisnu Wijayanto, PhD, from Universitas Diponegoro, Indonesia.
Profesor Yoshinori Yamamoto, PhD, from Kochi University, Japan. Profesor Wei Wen Chuang, from National Chiai University, Taiwan.
Assistant Professor Patavipa Songkumar, PhD, from Kasetsart University, Thailand.
Dr. Nick Norasma Jaya, from University Putra, Malaysia. Distinguished guests, ladies and gentlemen.
Good morning and welcome to the second International Conference on Agricultural Sustainability 2025. My name is Azril and my partner is
Virial.
It is an honor for us to guide you through this auspicious event.
Ladies and gentlemen, modern agriculture faces urgent challenges such as soil degradation, water scarcity, and climate change. This conference will explore more about innovative solutions, precision farming, climate-smart practices, renewable energy, and biotechnology.
Together, we aim to strengthen productivity while protecting resources for sustainable global food future.
To begin this special occasion, let us enjoy a traditional dance from Semarang, performed by our students.
Ladies and gentlemen, please welcome this opening dance performance, Gambyong Traditional Dance. Guided by the spirit of Universitas Diponegoro, noble and valuable.
We now invite you to watch the university profile video, Noble and Valuable.
On the move forward with a new spirit and tagline, noble and valuable. This spirit must become the driving force behind all aspects of our Tridharma activities, academic, research, and community services. Noble reflects the spirit and commitment to always uphold the values of humanity.
Versi ini memiliki masa yang lebih ringan dibandingkan versi yang sebelumnya. Dan kami sertai dengan teknologi Android untuk bisa mengubah pola gerakan yang akan digunakan oleh pasien.
We are determined to become a world-class university, to be part of global epistemic community that continues to carry out reproduction of knowledge for the future of humanity.
Terkait tantangan global, keuangan yang stabil diharapkan keuangan domestik juga tetap solid.
Valuable signifies our unwavering commitment to remain connected with societal challenges.
Ini air laut, ini air dari mesin desalinasi siap minum.
We strive to consistently be a proactive agent of change, delivering solutions for the various problems of the nation.
Sebagai bentuk pengabdian kepada masyarakat, kami siap menyehatkan masyarakat dan memasyarakatkan kesehatan.
We are determined that Universitas Diponegoro will continue to strengthen its competitiveness on the international stage, fulfilling its vision as a world-class university by producing exceptional and highly skilled graduates. With a new spirit and tagline, noble and valuable, We are confident UNIF can make a meaningful contribution to local and global communities.
Undip
Bermartabat, bermanfaat.
Ladies and gentlemen, next agenda is singing national anthem of Indonesia Raya. May I kindly invite you to rise.
Please be seated.
Ladies and gentlemen, we humbly invite the chairman of this event to present the chairman's report. Please welcome Mr. Albertus Fajar Irawan, PhD.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. My name is Albertus Fajar Irawan. I am really pleased and honored to meet all of you in this conference room in this very beautiful day. Welcome to Semarang, the capital of the Central Java Province. On behalf of the organizing committee of the Second International Conference on Agricultural Sustainability, I would like to welcome an Honorable Vice Rector Universitas Diponegoro, Dr. Wijayanto, for research collaborations, innovation, and public communications. Vice Dean of the Faculty of Animal and Agricultural Sciences, Professor Agus Tiadi. Head of the Department of Agriculture Science, Dr. Ahmad Nimatullah Albari. All honorable lecturers of Agro-Ecotechnology Study Program, honorable keynote speakers, my respected supervisor, Professor Emeritus Yoshinori Yamamoto from Kochi University, Japan, Professor Didi Wisnu Wijayanto from Agro-Ecotechnology, Professor Hue Wen Chuang from National Chiai University, Taiwan, Associate Professor Patavipa Songkumar from Kasetsat University, Thailand, Dr. Nikno Rasma Jaya from University Putra, Malaysia, and also distinguished and presenters and participants. Thank you very much for your presence, generous support, and for sharing your valuable insights and novel contributions for this conference. We are truly honored to have you with us. Today, in this event, the organizing committee would like to extend our deepest gratitude to the keynote speakers, esteemed presenters, distinguished guests, dedicated researchers from diverse scientific disciplines, as well as our proud students who have contributed to the success of this hybrid conference. This event has welcomed approximately 110 participants from across the globe, including 104 presenters who join both online and outside. The number of the online presenters is around 40%, and the remaining ones is the on-site presenters. We are honored to host contributors from various countries, from Indonesia, Malaysia, Uzbekistan, the Philippines, Rwanda, Taiwan, Hungary, Georgia, Turkey, Pakistan, and also from Gambia, West Africa. Thank you to all who submitted their impressive work to this conference. And we are pleased to announce that our conference has a collaboration with international proceedings in Scopus Index, Bio Web of Conference, and also 2 Scopus Index journals for special uses. We will do our utmost to support the publications of your interesting papers through this platform. The committee remains committed to delivering a conference that is both engaging and beneficial for all participants. We sincerely apologize if there were any shortcomings in providing timely and essential information. However, your feedback is highly valued, and we welcome any suggestions and to improve our future programs. Please do not hesitate to contact us should you require any assistance. Finally, as a chairman of the organizing committee, I would like to express my heartfelt appreciations to all college, committee members, the student technical team, and everyone who worked tirelessly to make this conference possible. We fully understand that organizing such as an event demands significant time and energy, and we are truly grateful to your dedications. Let us continue to foster research networks and collaborative efforts among participants. May the knowledge shared throughout this conference deliver meaningful benefits to our communities and all of us, and may it inspire the progress toward a better future of humanity. Thank you very much once again.
Thank you, Mr. Albertus Fajar Irawan, PhD, for your report.
Ladies and gentlemen, it's our honor to welcome Vice Dean for Research of Faculty of Animal and Agriculture Science.
I'm honored to invite Professor Agus Setiadi to deliver his welcome speech.
Good morning. Assalamualaikum warahmatullahi wabarakatuh. Distinguished guests, keynote speaker, presenter, and all of participants. I'm sorry because our dean now still in China, so he asked me to be a representative as give the welcome address to all of you. But warm regard from him to your all, so this international seminar will be success. We are truly honored to host the second international conference on agricultural sustainability, or ICAS 2025. Thank you for the distinguished guests, Pak Wijayanto, PhD, the Vice Rector of Research, Innovation, Cooperation, and Public Communication. Dr. Heni Rizkyati, the Vice Dean of Academic and Student Affairs. Dr. Ahmad Nikmatullah Albari, the Head of Agricultural Department. Dr. Sri Sumarse, Head of Animal Science Department. Dr. Eni Futska, the Head of Agroecotechnology Bachelor of Agroecotechnology. Insinyur Kustopo Budi Raharjo, the Head of Agribusiness Bachelor Program. Sivi Gayatri, PhD, the Head of Master of Agribusiness, and of course a faculty member of the Bachelor Program in Agroecotechnology, and all of students that attend the international seminar. We are honored our distinguished keynote speaker, Professor Hu Wen Chuang for National Chiai University, Taiwan. Dr. Patavipa Sungka Maru from Kasetsat University. Dr. Nick Norsma Ceya from University of Putra Malaysia, thank you. Professor Yoshinori Yamamoto from Kochi University, Japan, and Prof. Didik Wisnu Wijayanto from Universitas Diponegoro. Their keynote speaker will give the diverse expertise and will provide comprehensive insight and stimulate visionary dissemination knowledge of sustainable agriculture innovation. This year, the second ICAS will have 110 participants with 104 selected paper will be published in the index Scopus for Proceeding and also journal. The participants come from the many countries such as Indonesia, Malaysia, Kazakhstan, Taiwan, Hungary, India, Sri Lanka, Turkey, Georgia, and the Philippines. The global participants reflect the importance of international collaboration in addressing the universal challenges on agricultural sustainability. The presented paper come from the multidisciplinary fields such as agronomy, agribusiness, soil and land management, food technology, food and disease management, and agricultural biosystem engineering. In our sincere hope that conference will serve an catalyst from collaboration, meaningful exchange of innovative research, and significant contribution to the future of agricultural sustainability. Finally, I would like to give deepest gratitude to the organizing committee, keynote speaker, and all of participants that give the dedication to be conducting the ICAS 2025 possible to do. So, welcome and enjoy to the seminar. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Professor Agus Setiadi, for your welcome speech. It is truly a great honor to have with us today the Vice Rector for Research, Innovation, Cooperation, and Public Communication.
Ladies and gentlemen, we kindly welcome Mr. Ruwijayanto PhD to deliver his opening remarks and officially open the second International Conference on Agriculture Sustainability.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. First of all, let me express a very, very warm welcome to Semarang, to Diponegoro University. I hope you enjoy the city and also you are impressed with the university. The Honorable Dean of Faculty of Animal and Agricultural Sciences, Professor Sugiharto, which in this regard represented by Professor Agus Setiadi as the Vice Dean of Resources, Faculty of Animal and Agricultural Sciences, Vice Dean of Academic, Dr. Henny Rizkiati, Head of Department of Agriculture, my colleague, my friend, Dr. Ahmad Ni'matul Al-Bari, it's a long name. Head of Department of Animal Science, Dr. Insinyur Sri Sumarsih, the honorable keynote speakers, distinguished guests, respected deans, vice deans, heads of departments, lecturers, researchers, practitioners, and students, both attending on-site and online. On behalf of Diponegoro University, I am deeply honored and privileged to welcome you all to the second International Conference on Agricultural Sustainability, ICAS 2025. As mentioned by the chairperson of the organizing committee, Dr. Albertus Fajar Setiawan, this conference is held in a hybrid format, both at this hotel, Grand Candi Hotel, and virtually, serving as an international academic forum to exchange ideas, strengthen collaborations, and discuss critical issues in sustainable agricultural development. We are truly delighted to welcome our keynote speakers who are here to share their valuable knowledge and experiences. Professor Hui Wenchuang from the National Chiayi University, Taiwan. This is not your first time here in Indonesia, but first time in Semarang. I hope you're impressed to Semarang with the city. So far, couples of city you have visited. I hope Semarang will be one of the most impressed one for you, the most beautiful one. Dr. Patavipa Songkumar from Kasetsart University, Thailand. This is also not your first time in Indonesia, but your first time in Semarang. I hope you also enjoy the city. Dr. Nick Norasma Jaya from University Putra, Malaysia. Selamat datang. Professor Yoshinori Yamamoto from Kochi University, Japan. I envy Professor Yamamoto because he's been traveling around Indonesia. He's been to Papua as well, which I've never been there. You know, Prof. Agus here never been to Papua too. We have to go there very soon, Prof. Agus. And also Prof. Didi Wisnu Wijayanto from Diponegoro University. I have to mention with him with special emphasis because he has my name there. Even though the spelling is different, yeah, Prof. Didi. May this year, I traveled with Pak Rector to Taiwan with Prof. Didi. And we travel from end to end, and we really enjoy Taiwan as well. I guess I've been to Thailand, I've been to Japan, Malaysia, and also to Japan. Yeah, so all the cities of the speakers, I've been there, but I've never been to Papua. The theme of this year's conference, Agriculture and Biosystem Engineering Innovations for Sustainable Food Production, reflects our shared commitment to addressing global challenges in food security, climate change, and sustainable resource management. As you could see in our video of our company profile, Undip comes with a new tagline, noble and valuables. We would like to be part of the global epistemic community. Noble means that we would like to be productive in research, in the production of knowledge, of sciences. And valuable means that we would like to, based on our research, contribute to the betterment of the society. And I believe in Indonesia, as elsewhere in the world, the issue of food security, sustainable food production is a very important issue. Our president has mandated that in his program called Nawacita, food security is one of the main agenda. So this is a very important issue. And right now, regarding water in Diponegoro University, we created the desalination machine in which we converted seawater into drinkable water. And this is very beneficial for our community living in the coastal areas with tidal flooding, that it makes them difficult to afford drinkable water. And our scholar has invented the machine for desalination, now work together with Central Java province, with some regencies in Central Java, such as Demak, Blora, Jepara, Gerobokan. And in fact, as I'm talking to you right now, our rector is currently ongoing to Blora for another desalination machine launching. In Blora, this is not a seaside, but this regency has a problem of water. So the water is infiltrated with some, I don't know the term in English, but some kapur. So, you know, it's not drinkable, and it can reduce the quality of the food and also the quality of the health of the people. And with our desalination machine, we converted that polluted water into drinkable water as well. And I believe this conference will be one of the places in which innovations are invented, and it will later on contribute to society. A month ago, we have guests from QS, consultant, and they have, there are two main things, two main messages that is delivered. First, actually, we are proud that in the last 5 years, Diponegoro University has achieved consistent increase in terms of ranking in the last 5 years. That last year in Macau we got achievement awards, that the Diponegoro University constantly increased our ranking. And this year only, compared to last year, our ranking has increased in more than 100 ranking. So last year we were 722, and this year we are 620. So the increase is more than 100. However, we still have to improve in 3 areas. First is in the publication and citations. Second is in the international research network. And the last one is in international students. So hopefully with this conference that Prof. Agus, Dr. Fajar, Dr. Fajri have led together, it will produce more and more papers, more and more citation, and also create international research network. And hopefully our speakers and our participants from all over the world, from 9 countries in the world, when they go home, they will tell their colleagues or their students to continue the study in Diponegoro University. So we have more and more international students. With that, I strongly believe that the discussion and collaborations within this forum will strengthen academic partnerships, generate innovative ideas, and contribute meaningfully to the future of sustainable agriculture. Finally, with profound gratitude and optimism, I hereby officially declare the 2nd International Conference on Agricultural Sustainability 2025 open. May this conference bring inspirations, benefits, and impactful outcomes for the advancements of agricultural sciences and for the welfare of society. Last but not least, I would like to express my deepest gratitude on behalf of the university to the faculty of agriculturals and animals, to Prof. Agus, to Dr. Fajri, and all students who are here helping the success of this conference. Thank you so much again. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Mr. Wijayanto, for your inspiring opening remarks and for officially opening this conference. Ladies and gentlemen, let's move to the photo session.
We would like to invite Vice Rector, Vice Dean, speakers, Head Department of Animal Science, and Head Department of Agriculture to kindly rise for the photo session. Please raise. Okay, I will start with the first pose, noble. Place your right hand on your left chest. On my count, 1, 2, 3. Next, the second pose is valuable. Sarangeo. Ready? On my count, 1, 2, and 3. The third pose is victory. Please clench your hands strongly. On my count, 1, 2, and 3. Thank you very much. Let's give a warm round of applause.
Ladies and gentlemen, You may now be seated again. Now we'll proceed to the first plenary session. This session will be guided by Ms. Aisyah Surya Bintang, Master of Science, as the moderator.
Ms. Aisyah Surya Bintang is a lecturer from Agroecotechnology Study Program. She graduated from University of Gajah Mada and her expertise in plant pathology. Please welcome Ms. Aisyah Surya Bintang.
Oke, Assalamualaikum warahmatullahi wabarakatuh. Om Swastiastu, Namo Buddhaya, Salam Kebajikan. Good morning, distinguished guests, keynote speakers, and all participants. Welcome to the second International Conference on Agricultural Sustainability 2025. It's great honor for me to serve you as moderator in this session with the theme Agriculture and Biosystem Engineering Innovation for Sustainable Food Production. My name is Aisyah Surya Bintang, and I'll be the moderator for the first session. Ladies and gentlemen, agriculture and biosystem engineering innovation play a crucial role in achieving sustainable food production. This innovation integrates advanced technologies, engineering solutions, and ecological principles to improve agricultural efficiency while reducing environmental impacts. Key areas include precision farming, smart irrigation systems, renewable energy use, organic farming practices, and biostimulant application to enhance crop resilience. By combining engineering approach with sustainable practices, these innovations help ensure food security, adapt to climate change, and promote resource-efficient farming system for future generation. Today, we will be listening to 3 distinguished professors who will share their valuable insight, experiences, and research findings related to the challenge and opportunities in sustainable agriculture. It's an honor for me to invite our honorable speakers to join us at the stage. So, Professor Didi Wisnu Wijayanto from Indonesia. Professor Yoshinori Yamamoto from Japan. And Professor Hui Wen Chuang from Taiwan. Okay, so please give big applause to our keynote speakers. Okay, so we will start the first session for this morning. So the first speaker is Professor Didi Wisnu Wijayanto. Professor Didi will present on the topic why should organic farming be implemented, learning from Indonesia's experience in achieving rice self-sufficiency. So before we start, let me introduce Prof. Didi. So Professor Didi Wisnu Wijayanto, PhD, is a professor of agroecotechnology from Department of Agriculture, Universitas Diponegoro. His education background: Bachelor at the Faculty of Animal Science and Fisheries, Diponegoro University, Department of Animal Science, Master of Soil and Environmental Science, Edinburgh University, PhD on Soil and Soil Fertility, Kagoshima University, Postdoctoral Fellowship, Guangdong Institute of Soil and Environmental Science, Guangdong Province, China, and Postdoctoral Fellowship, George August University of Göttingen, Germany, and his professional appointment as Embassy of the Republic of Indonesia as Attaché at Papua New Guinea. So, Professor Didi, so we have 25 minutes for you. So please present your topic to all audience. Yes, sure.
Distinguished guests, especially for the keynote speaker, I give you highly well, good morning everyone. Thank you very much for coming to join with the seminar. Good morning, selamat pagi, ohayo gozaimasu, sensei. Chao Sangho, Professor Chuan, and selamat pagi, Dr. Ni Chokya, yeah? Okay, and everyone who joined with and participation to the ICHES 2. Actually, we have the first ICHES when we got COVID period at this time, 2-3 years ago. I think 3 years ago. And it was online, but today we may do this conference offline. I really give high appreciation to all of the keynote speakers from Taiwan, from Malaysia, from Thailand, and from Japan. I really appreciate because you come from really far away, especially Yamamoto sensei. You flew 9-10 hours from Japan, right? It's very, very hard actually. Assalamualaikum warahmatullahi wabarakatuh. Salam, namo buddhaya, rahayu, rahayu, rahayu. Terima kasih. This morning, I would like to share our experience. Why should organic farming be implemented? Why I took this theme? We learn about the Indonesian experience in providing rice self-sufficiency. We learn from that. I believe that all of us knows what is organic farming, because our ancient million years ago started cultivation with organic, no unorganic at all. We knows, but yeah, willingness to pay to practice organic farming, very few. The development of organic farming up to now, like in Indonesia, is less than 3%. In Japan, maybe less than 5%. Maybe in Thailand, you have more. I mean, the practice of organic farming. So we discuss this theme. Sorry. Well, the outline will be introduction, intensive agriculture, sustainable agriculture, organic farming, and conclusion and recommendation. When we talk about food, of course we talk about population, the growth rate of population. I'm sorry to who not know Indonesian, I forgot to convert this Indonesian, but I just translate jumlah penduduk mean that population. And then laju pertambahan penduduk mean growth rate of population. We can see of Indonesia from 1961 when we first time got population census, and then every 10 years we got population census. 2020 our population is where is it? Well, sorry. Our population is 270. The biggest in Southeast Asia, even higher compared to Japan. Our population is the fourth now in the world. So, but the growth rate of population before, about 1960s and 70s, 80s, so it's very high, 2 point something. But the government at that time just stated, we should have self-sufficiency of rice, because rice is the staple food, right? And then we try as well, apply as well the family planning to meet between the need of rice and the production of rice. And this population, now Indonesia just concerned on the 2045, 1 years we got independent. So our population will be more than 300, because now it is predicted that the increase of population is 2.5 million a year. So mean that in 20 years we got 320 something. This will be influence the condition of course, insufficient. I think everyone knows why Indonesia still import rice, import soybean, import corn, and so on. Then we apply intensive agriculture. When we apply intensive agriculture, at that time about 1970s, when our friend, our brother in Germany, campaign about organic farming, and then asked Indonesia, why you now, we campaign organic farming, you apply intensive agriculture. Yeah, because we need rice a lot. Last year, we need 90 million ton rice. And we produce only 83 million ton. It means that about 90%, but still need 10%. We import from Thailand, from Vietnam, and other countries. Thank you, Dr. Song Kaman. Yeah? We import rice from your country a lot, I think. And then we try apply the intensive agriculture. We have five standard agriculture. Sorry ya, kok macet ya. Okay. At that time, we apply high quality of seed. And then best practice of soil management, irrigation, pest disease control. We started in 1970s. We apply intensive agriculture. 10 years later or 15 years later, we got rice self-sufficiency. That 1984. Yeah, before we import rice. 1984 till end of 1990s, we self-sufficiency. We not import at all. We just give, yeah. Indonesian is very, what is called it? When we got a lot and then we just sell our production rice to Tanzania and many other countries. Even now import about 4.8 million ton. We give Palestine 10,000 ton, I think. Yeah. We just send it. This 5 practice we call Panca Usaha Tani. Panca is 5, Usaha Tani is agricultural basic or something like that. Sorry. Of course, when we self-sufficiency of rice, we do not need import. We do not need budget to buy a rice. We sell our rest of our production and to other countries. But what we should learn, this the impact. The impact of intensive agriculture. Now, you know, if you go throughout Indonesia, yeah, I think Yamamoto Sensei been throughout Indonesia. I myself throughout Guangdong province. We know, actually in Guangdong they have a problem as well because of intensive agriculture. I stayed there for 3 months and then throughout Guangdong. That's why we propose organic farming. I think everyone knows organic farming. The theory is very easy, organic farming. But how to practice? You may ask later on with Yamamoto Sensei, how about in Japan? How about in Thailand? How about in Taiwan as well? The philosophy is reduce, recycle, and reuse. We only use the organic material in the system. I have a farmer, we work together in Semarang district. They run around more than 100 hectare rice organic. And now they sell rice to Middle East, to Arab Saudi, to Yemen, to Kuwait, and so on. Anunya di mana Pak? Videonya di mana? This is not working. Mas nggak working, nggak buka. Anu balik ke tadi, balik ke tadi. Ini tinggal balik aja. Sorry, technical thing, yeah. Okay, just leave it this one. Organic farming is practicing organic, no artificial chemical substances, whatever, fertilizer, pesticide, herbicide, insecticide, we use natural thing. We avoid using artificial chemical substances. We believe that using that natural, so we may save our land, our soil, our environments. Yeah. So believe or not, yeah, using organic means that we may feed our crop not directly, like using urea, phosphorus, calcium, whatever, in chemical form. When we apply organic matter to the soil, it will be mineralized. That takes about 3 weeks. If we use EM4, effective microorganism, 1 week to 2 weeks. Last time, May, this year, I went to Chongqing University, and I got information that they convert manure to fertilizer is only 4 hours using special enzyme. So I'll try to learn about that. That is really great news, because what is called it, when we have we may convert from manure to fertilizer faster, then we may increase our productivity of crop faster as well. We may maintain our soil, we may maintain our environments. But there are a constraint. Yeah. Because like people, for example, in our country, my experience, the willingness to pay doing or practicing organic farming is still very low. Yeah. The price of organic farming product higher than unorganic product. To have certification, that is not very cheap, especially when we will sell our product outside, abroad. We should certify with the international bound for this certification. So that's all the constraint. But I encourage all of us, if we want to be our organic, our agriculture sustainable, we should at least, well, organic farming is not the only one. Yeah. We have like integrated farming system. We have like best practice in organic. We have laser, low, external input sustainable agriculture. So which one we choose? So time is up. Okay. So we try to maintain our soil and our environment better. Yeah. Of course, one day I was asked by my student, "Sir, it means that all of the agricultural activity should be organic?" Not at all. Yeah. Because we need going down, and then the production, of course, do not enough to meet with the needs. That's the problem. It means that we should do our activity, both organic and unorganic, simultaneously. That's all from me. Later on, maybe we may discuss, because we got a problem with our what is called high technology. Yeah. Like in organic farming, high technology, but compared with organic farming, maybe different as well. Thank you very much indeed. 谢谢你。 Terima kasih. Kang Kun, thank you very much.
Thank you very much, Professor Didi, for your insightful presentation. Now we move to our second keynote speaker, Professor Yoshinori Yamamoto, who will address the topic issues facing rice cultivation in Japan due to global warming. So before Professor Yamamoto present his presentation, let me introduce his profile. Professor Yoshinori Yamamoto. He is Professor Emeritus from Kochi University. His education background graduated from the Faculty of Agriculture, Kochi University, graduated from the Graduate School of Tohoku University. His research studies on the cultural significance of transplanting injury in rice plant, ecophysiological characteristics of high-yielding rice cultivars, studies on the starch accumulating palms in the tropics, and also studies on the biomass and starch productivity of edible kanna in the southern district in Japan. So, Professor Yamamoto will shed light on the challenges posed by climate change, particularly global warming, and how it affects rice cultivation in Japan. So Professor Yamamoto, so you have 25 minutes for your presentation, so time and floor is yours.
Thank you. Thank you, Ms. Chairperson, for your kind introduction. Selamat pagi. Good morning, everybody. My name is Yamamoto Yoshinori from Japan. So, first of all, I'd like to express my sincere thanks to the rector of Diponegoro University, Suharu Nomo, and the dean of the Faculty of Agriculture, the Professor Sugiharuto, for giving me this special occasion. So, and also I'd like to express my deep thanks to all the members of the organizing committee of this conference. So today, I'll talk about the current topics of rice cultivation in Japan, titled The Issues Facing to Rice Cultivation in Japan Due to Global Warming. So this is the contents of my presentation. Firstly, I'd like to talk about the greenhouse gas global warming and rising temperature in Japan. And then I'll talk about the effect of rising temperature during the rice growing period, how affects on the development of brown rice. And then finally I'd like to talk about the countermeasures to global warming. So maybe you know very well that these figures. So this is the change in the atmospheric concentrations of major greenhouse gases. These gases began to increase after the Industrial Revolution around including since the 1980, and by 2023, the concentration of the carbon dioxide had reached to these concentrations. The IPCC, you know the IPCC maybe, so reported that the increase of the greenhouse concentrations is causing the global warming. This figure shows the differences in the global average temperature from 1980 to 2023. Using the 1991 to 2020 global average temperature at the 0°C here, baseline. So our warming trend is observed over the years, and with the particularly the increase the observed since the 1980. During the over 100 years from 1890, the global average temperature has risen by 0.76 degrees Celsius. This figure shows the differences in the annual mean temperatures of Japan from the average temperature for the period 1991 to 2020, taken as 0 degrees Celsius, from the 1898 to the 2024. So a warming trend is observed also in Japan, and the average temperature during the over 100 years has risen 1.4 degrees Celsius. And also the years with temperatures higher above the average frequently occurred since 1990 here. And especially in the 2020, the temperature in 2023 and 2024 were higher, nearly 1.5 degrees Celsius than the average temperatures. Okay. This figure shows the cultivation in the agriculture region, major cultivation period in the agriculture region in Japan, from the north area Hokkaido to the south area Okinawa. So excluding the early season culture in Shikoku and Kyushu, as well as the double cropping in Okinawa regions, the transplanting typically occurred in shown by the green bars, typically occurred in May to June, and heading in July to August, shown by the brown bars, and harvesting shown by the red bars in September to October. Okay. So let's look at the recent changes in the temperature during the rice cultivation seasons. So this figure compare the monthly average temperature in 2024, shown by the red line graph, with the normal temperature, that is the 1990 to 2020 average temperature, during shown by the blue bar graph, during the rice cultivation period, that is May to October, just I mentioned in the previous slide in Japan. So temperatures in all months in 2024 higher than the normal temperatures, with the difference being profound from the July onward. That is this period corresponding to the rice, the grain filling period after heading, just I mentioned in the previous slide. So this is let's look at the starch accumulation in the endosperm cells. This figure shows the route of translocation of assimilate into the endosperms. One large vascular bundles located on the dorsal side of the grains, and assimilates produced in the leaf flow into the endosperms through the vascular bundles. And starch accumulation, starch deposition proceeded in the order of the center of the endosperm, the surrounding, and the dorsal, ventral side and the dorsal side, and finally the basal part. So next, let's look at the what happened to the starch synthesis in the endosperms under the high temperatures during the grain filling period. So under the grain filling period, under the high temperature grain filling, during the grain filling period, the sucrose translocation to the endosperm is inhibited. And also the and also the breakdown to the breakdown of the sucrose translocated to the endosperm to the monosaccharide, such as the glucose and the fructose, also the declined, and translocation of the monosaccharide to the amyloplast also the inhibited. So within the amyloplast, the enzymatic activities responsible for the starch synthesis decreases, while the degradation of the synthesized starch is promoted, resulting in resulting in overall reduction of starch synthesis. So please proceed one slide. Cannot control. So just I mentioned, when the starch accumulation in the endosperm is insufficient, not enough, the affected portion to be the opaque, white, to be white colors, just these, and the decrease the grain weight. The affected portion, white portions, is related to the timing of the starch accumulation in the endosperms, and these grains exhibiting these white portions are collectively regarded as the immature white kernels, or the immature white grains. So, and classified into the according to the white portions, just shown here by dotted parts. So white belly, white center, white core, white back, white base, white side, and milky white, just like that. Here I show the perfect grains. Perfect grain is the starch accumulation in the endosperm is sufficient and without the white portion. This figure shows the side and the cross-sectional view of immature grains with white portions. So milky white kernels appear the whiteness in the oval state in the center of the grains, while the white backed and white based show the white on the dorsal side and the basal parts respectively. Okay, this figure shows the relationship between the temperature during the grain filling period and the percentage of perfect grains. Just I mentioned already, perfect grains will accumulate the starch. So you can see that when the average temperature over the 26 or 27, the percentage of perfect grains sharply decreased. On the other hand, this figure shows the effect of average temperature during 20 days after heating on the immature grains with white portions. So when the average temperature over the 26 degrees Celsius, the immature grains with white portions increased so much, very rapidly. In Japan, the rice intended for official sale must undergo the grading inspections. So grading inspections is conducted in the brown rice states, and the grading is determined by the just shown here, the perfect grain, water content, and the damaged grains percentage, and falling grains, falling matter percentage, and so forth. And the grade and the grains graded into the 4 classes: first class, second class, third class, of grade. And the differences in grade is reflected in the selling price. Okay, so this figure shows the sorry, this figure shows the relationship between the latitude of prefectural capitals, this one, north to the south, and the average temperature during in August and September. That is corresponding to the grain filling period of rice. So in this figure, I show the average temperature in 2024, compare the average temperature in 2024 with the normal average temperature from 1991 to 2020. The temperature in 2024 in all the prefecture shown by the red circle, higher than the average temperature during the 1991 to 2023. And there are 26 cities in during the 1991 to 2020 with temperature at 26 or below. 26 degrees Celsius, just I mentioned, the threshold temperature. Over this temperature, above this temperature, the immature white grains sharply increased. So, but the number in 2024, number is declined to only 7 cities. Limited to the northern area, Hokkaido, and the prefecture belong to the Tohoku area, northern North District. So against this background, now in Japan, national and prefectural agricultural research center has been developing and disseminating of heat-tolerant rice varieties as a countermeasure to global warming. This figure shows the planted area and the planted area ratios of these heat-tolerant rice varieties. So gradually increase the planted areas. And in 2024, planted area attained 204,000 hectares, account for the 16.2% of total cultivated areas. So this figure, this table compares the first grade rice percentage between the recently developed heat-tolerant varieties shown by the blue line. These, and with the koshihikari varieties. This koshihikari is a very famous variety in Japan. because it's very delicious and most widely cultivated in Japan. So about the 1/3 of the total cultivated areas and for the over near the 50 years. So compared to the this koshihikari, the newly developed varieties show the higher percentage of the first grade rice percentage. And also these varieties, these new bred varieties, the quality, eating quality is also the equal to or the higher than the koshihikari. Okay, this is the conclusion. The temperature during rice season in Japan is rising due to the global warming. The rice grain quality is lowering due to the increase of immature grains with white portions caused by the high temperature, especially the over the 26 degrees Celsius during the grain filling period, especially in the regarding to the district in the southern parts of Japan. To solve the problem, the new varieties with tolerance for high temperature and high yielding quality have been breeding and developing. Okay. This is my presentation. Thank you very much for your attention.
Thank you very much to Professor Yamamoto. So we will move for the third session, third speaker for this first session. Okay, next we will have Professor Wei Wen Chuang, who will talk about enhancing horticultural crop resilience, current perspective on biostimulant-based strategies for abiotic stress tolerance. Professor Wei Wen Chuang is a professor from Department of Agricultural Biotechnology, National Chiayi University, Chiayi, Taiwan. Her education background, PhD in genetics from Texas A&M University, College Station, Texas, USA, MA in horticulture, National Chung Sing University, Taichung, Taiwan, and BA in horticulture from Chinese Culture University, Taipei, Taiwan. Her research about unveiling the molecular mechanisms underlying plant defense responses to various environmental stresses, examining the effectiveness of biostimulants in alleviating stress-related damage in crops, and formulating biostimulants to promote crop growth and strengthen stress resilience. So to Professor Chuang, you have about 25 minutes to present your topic. So the time is yours, please.
Thank you for the kind introduction. Okay. Is this starting yet? Okay. So today's topic is working on, going to focus on using the biostimulants on decrease the negative impact of abiotic stress or stress, other kind of stress on the crop. And we're going to focus on the research on the horticultural crop, okay? And so going to give you a brief introduction about the commonly seen or discussed abiotic stress nowadays. It's including drought stress, salinity, heavy metal stress, heat stress, and the hypoxia stress, okay? And drought stress, most of you understand that drought stress causes lots of osmotic stress, and then later we reduce photosynthesis effect, and then leading to the accumulation for RS molecule. And then the salinity stress, in addition to osmotic stress, it causes some ionic toxicity, and also the affect the nutrient uptake for the plant. And then heavy metal mainly is causing RS stress, and then will lead to denature of the protein. And for heat stress, you can see obvious effect in the plant is for denaturing of the protein and will destruct the membrane integrity, and then that will lead to accumulation of ROS molecule. For hypoxic stress, it also create environment for a nausea environment, and then leading to accumulation of acidity. And you can see there's a common theme for those abiotic stress affecting plant growth is there were increased ROS molecule accumulation, and then making the membrane damage, and it will cause reduction in photosynthesis and lead to the growth reduction. And so, give a brief introduction for biostimulants. And so there's a definition for biostimulants, and then usually we are considering it's a biostimulant or not. We're thinking it's a substance or microorganism that will activate plant natural process to enhance plant growth. Okay, and then there's many different kind of classification for biostimulant. Here is the simplest one. Usually you group the biostimulant as like a seaweed extract, humic acid, and protein hydrolyzed or beneficial microorganism. And so those biostimulants should be able to activate plant gene expression. And later you can see those gene expression will lead to the protein synthesis involving in antioxidant defense, and then affecting plant nutrient growth, nutrient uptake, and then will affect the gene that is involving in response to those stress. And then, so you can see in plant, you can see plant getting more synthesis for chlorophyll content, and getting a higher photosynthesis efficiency, and increase plant antioxidant activity, and later they will improve plant metabolism for primary metabolism or for the secondary metabolism. And later you should, the last one you can see, they should affect plant the stomata conductance, so making plant have higher photosynthesis efficiency, such as they can get higher value for relative water content, and then improve plant root and shoot growth, and then increase plant's tolerance to the abiotic stress. So here is today, because there's so many different kind of biostimulants, today we're going to just focus on beneficial microorganism, and generally called plant growth promoting rhizobacteria. If it is you're working on the fungus, they will call PGPF. Okay, and this very simple figure will show you. So this is the old one. Okay, all right. So this is a very simple figure will show you how those PGPR promote plant growth, and by producing like a salaraphore or like a hormone, and also maybe some microorganisms they get doing like a nitrogen fixation. And some PGPR they can increase solubility of phosphate in the soil, and then some PGPR they can produce some antibiotic compound, or they can induce plant systemic tolerance to the plant. Okay, so the last two categories will increase plant disease resistance. And so today I'm going to focus on mostly abiotic stress, and here I show you some mechanism how PGPR can promote plant tolerance to abiotic stress. And so some PGPR they might produce some like osmolyte in their metabolism. They can produce osmolyte, and this osmolyte can maintain plant osmotic pressure when plant grow under the abiotic stress. And some PGPR they may produce some volatile organic compound we call VOC, and those VOC can activate plant gene expression against some abiotic stress condition, and also they can regulate stomata movement. And some PGPR they can produce like plant hormone like IAA or cytokinin affecting the root structure, and so they make the plant grow healthier under the stress condition. and some PGBR, they can produce ACC deaminase, reduce ethylene production under stress condition. And some PGBR, they can produce metabolite that will activate plant redox reaction. So they can activate plant defense response, and some PGBR even produce like a cellular. They will chelate some iron, so make plant grow healthier under a stress environment. And some PGBR can produce kind of polysaccharide we call EPS that will get in the. They can keep more moisture in the soil, and so also protect plant roots from the attack from a pathogen. And today we're going to focus on one PGBR that we studied several years ago, and we published 2 papers for this one. And this PGBR we call is Pseudomonas aeruginosa, and for this particular strain, it's been in this field. It's been published in plant growth. They have shown plant growth promotion because they can produce some plant hormone like IAA or cellular-4. And somebody report they can produce antibiotic compound working for biocontrol and also activate plant immunity. And some publication is mentioned about this one this bacteria metabolite can activate plant antioxidant activity. Okay, and so in our lab, when we're working on this one, we check whether the gene expression this bacteria strain can have the gene involved in synthesis of antibiotics compound. And we check in 2 compounds, is ranolipid and phenazine. Here is ranolipid and phenazine. This is a PCR product. Ranolipid is a kind of biosurfactant. You can use it as a kind of similar to antibiotic compound, but not exactly it's antibiotic metabolite. Okay, and the phenazine is being included one of the antibiotic compound, and this bacteria strain contain the gene fragment for involving in synthesis of ranolipid and phenazine. And next, the next one here is qPCR result. So we're looking for the gene expression. So this bacteria can express this gene involving in these 2 metabolite synthesis around after about 6 hours of culture. Okay, and the bottom figure here is this pathogen is causing banana fusarium wilt. It's a serious disease in banana, and then this bacteria PAY1 actually can inhibit the mycelium growth of this pathogen, and also this bacteria produce some IAA and GA and ranolipid. So banana plant, the first crop we're working on for using this PGBR is because it's very important crop all over the world. Okay, and then banana, in order to suffering the drought stress, also can suffering from the hypoxia stress, submerged or we call flooding stress, and also banana have a very serious disease. It's called Panama disease. It's caused by fusarium wilt. Caused by fusarium. It's FOC TR4 strain. And here's our results show that application of this PAY1 can promote banana vegetative growth. And this is some, actually we did not use the bacteria directly, we used the metabolite that we produce from this bacteria strain. And you can see this metabolite, we apply the metabolite of PAY1 to banana plant. You can see the plant go taller and then get greener, and then can produce more. This is total phenolic compound. This is total phenolic compound. It's kind of antioxidant metabolite. And then you can generate more lignin, so they will make a cell wall become stronger. And when we explore this banana plant to drought stress for 4 weeks, you can see the plant get less degree of the wilting in plant. And then you can see they got less amount of MDA. MDA is a compound from the membrane peroxidation. Okay, so the membrane becomes stronger when after you apply the metabolite from this particular strain, and you get less amount of electrolyte leakage. It means the membranes is become the situation become better. And then you can see this is when we recover from the drought stress. You can see the plant grow healthier, and then the root structure goes stronger. And you can see when we also expose this banana plant to how many weeks of, I think it's 1 week of submerge. We cover the plant with the water. And then you can see still you can this amount of MDA and the electrolyte leakage. And also you got more chlorophyll fluorescence. This is the indicator for higher photosynthesis efficiency. Okay, and then after we recover back in the greenhouse, you can see the plant treated with this metabolite. So they got a stronger plant here, and compared with the control plant, they got most of them got the group 1 wilty phenotype. And we also challenge this plant with inoculate with the pathogen, with the FOCTR4. And you can see this is the disease symptom we observe in the plant. And this is narcotic tissue where after you do the inoculation, if they show the disease symptom. And this is HIFA. You can really see during the dissection. And so when you treat it with this metabolite, you can see less amount of infection rate. And also you got the plant got more higher chlorophyll content, and then they got better growth condition. And so we did the transcriptome assay by using RNA-seq analysis. We want to see why this plant get healthy after you apply those metabolites. Okay, so don't worry about those genes name. Okay, so this we grew them to the gene that's upregulated gene by this metabolite that involve oxygen response, JA synthesis, and then ABA sensitivity. So we more interested in the gene involving synthesis. So that means this metabolite can activate plant gene synthesis JA jasmonic acid. Is a very important plant hormone that regulates plant disease resistance. And also in the plant treated with PAY1 in banana plant, those genes is upregulated, including the gene involving a biostress during the detoxification, and the gene involving in the biostress. You see the PR gene is a pathogenesis related protein, and then the gene involving cell death and MTI. MTI is called MLMP trigger immunity. Okay, it's very important disease response in plant. And then also the gene involving in the last one, can I see very clearly? Okay, there's all disease resistant gene involved in the plant expressed in the plant treated with PAY1. Okay, and we do this is a Western blot, so we do the Western blot to confirm the transcriptome analysis. Okay, so in the Western blot, you can see when the banana plant treated with PAY1 metabolite, they can activate gene involving PR1 is a pathogenesis related protein for disease resistance, and antioxidant is a SOD, and APX and catalase is all antioxidant in that. Okay, and then also there's some membrane proteins such as proton ADPS, and then some like alkylcholine and then dehydrin, and those genes is involving in disease resistance, and it's involving the drought stress response, and some genes just like lipooxygenase, LOC. This one is for JA synthesize JA precursor. Okay, so this is the Western blot we confirmed in banana plant treated with PAY1. So our our conclusion for the works banana plant is the PAY1 can produce phenazine, nanolipid metabolite to activate plant signal transduction pathway, and then making plant synthesize more jasmonic acid, and the jasmonic acid can regulate downstream gene that will make plant grow better, and then get more tolerance to drought stress, haphazard stress, and disease resistance. And the other plant we work on is the Phalaenopsis orchid, and because this one is a very important follow crop in Taiwan, and Taiwan is one of the major country produce Phalaenopsis orchid. And this orchid has a problem with slow growing because it's a CAM photosynthesis plant. And also this orchid suffering the low temperature stress because in Taiwan we have to export them to other country, and in that kind of carriage, they usually use low temperature to store those orchid, and it's suffering in addition to the drought stress, also the low temperature stress. And so apply this metabolite to orchid, and they also can produce the leaf growth in Phalaenopsis orchid. And then they will increase the leaf length and also the photosynthesis product, total sugar content, and they got more antioxidant activity, and this is another antioxidant activity. And PAL is phenylalanine ammonia lyase is not involving synthesis. That's our metabolite having the antioxidant activity, and then also increase the lignin content here. Lignin content. Okay, so that will make the cell wall get stronger. Okay, and then we expose this PA11 treated Phalaenopsis orchid to the low temperature. We use 10 degrees Celsius and expose it for 3 weeks. And you can see the lesion. You can see the lesion developing on the surface, and you can see the cursor here. Okay, and then we calculate the lesion appearing on the surface and found out the orchid treated with this metabolite get less amount of the lesion developing on the leaf surface. And also the NDA amount is lower, and also electrolyte leakage is lower by the treatment of this metabolite. And also we inoculate with Avinia pathogen. This pathogen causing bacterial soft rot in orchid plant, and then treatment of this metabolite can reduce the infection area in the orchid. And same thing, we expose this, we do the RNA analysis in the orchid. We want to ask why this orchid they can grow faster and stronger. So we found a similar response in this orchid is they got gene activated by this metabolite is involving JA synthesis, and also like ABA response and the salicylic acid response and oxygen response. But for GA and the cytokinin, the genes involving degradation or synthesis kind of a balancing, try to control the hormone homeostasis, and same thing like a cytokinin. So still, JA is the most important factor why this PAY1 metabolite will activate, improve this orchid growth under stress environment. And then in addition to the hormone signaling, this orchid also, the gene activated in this orchid also involving MTI, PR protein, disease resistance, and hypersensitive response gene, and then callus synthesis. And also involved in the abiotic stress like a cold stress and other abiotic stress, and also involved in cell strengthening gene expression. We also confirm with the orchid with the Western blot, and similarly you can see the antioxidant enzyme is induced higher level, and the gene involving in JA synthesis and the PR gene. Okay, so in the orchid plant, the similar thing we see here is this PA11 metabolite can activate JA synthesis, and then they will activate antioxidant and make the plant get stronger under cold strain environment. And also the data here we got it from mostly from the transcriptome analysis, This JA synthesis will activate transcription factor like a MYC50 and then activate the downstream gene such as gene involving ABA signaling and then get stronger on the co-strains, and also they activate the gene, the transcription factor involving in lignin synthesis and make a cell wall become stronger, and the cell wall factor will affect co-strain tolerance and also the disease resistance. So last one, we have a conclusion here is PA11, they can produce useful metabolite like phenosine and renolipid, which can activate the JA signaling pathway in banana and the Phalaenopsis orchids. And then the JA signaling will activate downstream signaling such as auxin and ABA signaling. And then finally, the PA11 can function as a multifunctional biostimulant to promote plant growth and enhance abiostrate tolerance and improve disease resistance both in banana and Phalaenopsis orchid. Okay, thank you for your attention. Okay.
Okay, thank you very much, Professor Chuang, and also thank you very much to Professor Yamamoto and Professor Didi. Your presentation enhance our knowledge, especially about technical agriculture and biosystem engineering innovation for sustainable agriculture. Okay, so for all the participants, we'll move to the discussion Q&A session. So if you join us on site at Grand Candi Ballroom, you can raise your hand and you can ask the question directly to our keynote speaker. And if you join us online by Zoom meeting, you can use the Q&A feature. You can use the chat feature on the Zoom box, and you can type your question, and later our committee we will send your question to us. Okay, maybe for the participant who join us on site. Okay, Professor Agus Setiadi. Okay, please. Okay, microphone. Okay. Okay, please, Professor Agus.
Okay, thank you very much, Prof. Didi, Prof. Yamamoto, Prof. Chuang. That the presentation is very interesting. For Prof. Didi, I want to ask, in fact, that the irrigation channel now already contaminated with the household residue. So, how the organic farming can be adapted by farmer, because the water now already usually is contaminated with household residues such as soap, etc. So in my opinion, that is very difficult to apply the organic farming to the farmer. So in your suggestion, how to make the farmer can be adapt the organic farming? Okay, for Professor Yamamoto, this is very interesting. I think the condition is also same with the Indonesian condition. So the temperature is hot. So I would like to know how to cultivate rice in the hot temperature like in Indonesia. We have just only two season, dry and rainy season, and the temperature also the same. The year by year is always increase. In Semarang, for example, we until 40 degrees Celsius, 40 or maybe if the up to 42 maybe. So how the strategy to still can cultivate rice, but the productivity still high also, if we still want to develop in Indonesia, how the strategy for that. And from Prof. Chuang, this is also interesting topic that in our faculty, we still develop the horticulture also, such as melon and etc. I would like to know the abiotic stress also can make in the horticulture like melon. How to mitigate the melon cultivation in the tropical countries such as in Indonesia? How to mitigate the abiotic stress can be reduce the productivity of the melon. I would like to know your opinion about the strategy to mitigate the abiotic stress in maybe, for example, in melon, such as melon in a tropical country like Indonesia. Thank you very much. I give to Master of to Bu Bintang. Thank you.
Okay,
Assalamualaikum
thank you
warahmatullahi wabarakatuh.
very much for the questions, Professor Agus Setiadi. Okay, so each speaker, you have question from Professor Agus. So maybe first to Professor Didi, the question about the residue from household. There is one of the challenge for the farmers, especially who want to implement the organic farming. Do you have maybe any strategies so the farmers can adopt? Because the problem about the residue from the household, maybe from the soap, yeah. So what do you think about that, Professor Didi?
Thank you, Prof. Agus, for your question. It's very great question. And I think later on maybe we can ask Professor Yamamoto, because different in Japan and with our country here in Indonesia, because we should be careful when we put the organic matter to the soil for doing organic farming. Like here, the house waste is sometimes just, well, in Indonesia we do not manage our waste separately like in Japan. In Japan it's very easy. If you to away the waste is different. You know, here everything in one, what is called, together everything. I mean, you have house waste, maybe if you have like even patre or something like that, and then you put together, even plastic, anything, and then we go to TPR, right? For the what's it called, the end of this shortage, and that's the problem. Later on, maybe Professor Yamamoto may have experience or explain the experience. You see, in Japan is totally different. I lived there for 5 years. They separated the waste, so it's very easy to maintain. Okay, this is for house waste, this is for electricity, this is for furniture and something like that. So easier to manage that thing, right? The important thing, for example, I did experiment on water hyacinth. Water hyacinth is OTAY, eceng gondok, yeah, in Indonesia. Ekornia. The water hyacinth absorb a lot of nutrition, a lot sometimes of heavy metal. We can see from the Rawapening Lake, for example. In Japan, I use as well. But we should be careful when we use the organic thing, but we should use we guarantee that the organic matter that we put to the paddy field, for example, that is in good condition. That's what can I say, Prof. Agus. Yeah, is that clear? Okay, thank you very much.
Okay, so we will move to Professor Yamamoto for the second question about how to adopt, especially maybe for the rice cultivation, right, Prof. Agus, especially in Indonesia with the high temperature, it's almost 40 degrees Celsius. So what do you think the best strategy for that?
Okay, thank you very much for your question. So there are big difference among the Japonica type rice and Indica type rice. Indica type is more tolerable to the high temperatures. And also the high temperature effects on the rice is different by the growth stage. So the before heading, especially during the tillering stage, you know the tiller, that is the stem, increasing the number of the stem come out from the mother stem, many tiller, we call it the tiller coming out. But under the high temperature, the number of the tiller reduced. So this affects the yield due to the few number of the panicles. And also the most serious damage is at the heading stage, flowering stage. Over the 35 degrees Celsius, just flowering time, fertilization is not so not well, so that cannot make a seed. So this is the most serious problem. In Japan already, around the 70% in the total area appeared in recent years. This failed to the fertilization. So completely no yield. And also just like today I mentioned the effect of the high temperature during the grain feeding period. The Indica rice is more tolerable than to the Japonica rice. But if the temperature is higher than 35, 40, you just mentioned, it's very, very difficult to where the starch accumulate in the endosperms. So in that case, the need to some genes, the tolerable genes introduced to the varieties. So anyway, firstly, we have to check find out of the tolerable varieties for the high temperatures. This is most important, first step. And then introduce the gene to our introduce to the new varieties. This gene introduce and new develop the new varieties. These are very important, I think. Yeah.
Okay, so maybe we can create the new variety using the gene insertion, or maybe we can use like transgenic plant, maybe sensei, right? So the rice can adapt to the high temperature condition. So for Professor Chuang, we have the strategy. Yeah. Prof. Agus asked about how can maybe the abiotic stress method maybe to improve the productivity for especially melon. Yeah.
Okay. I think for reduce the abiotic stress damage, biostimulant actually is a really good candidate. It's because it not only promote plant growth, but also increase plant resistance, not only for abiotic stress, also for biotic stress. Just that, and some of the mechanisms that I showed you previously. Okay, and because if you just use the chemical fertilizer, you don't really get the increase the resistance against the biotic stress or abiotic stress. That is the gain for using biostimulant. However, which kind of biostimulant is work for melon-based, you have to test. Give you a very simple example is because before OG get to my lab, we working on seaweed extra, and later we stop using seaweed extra because we don't really produce our own seaweed extra. We got it from the commercial market, okay? And there's not many different kind of seaweed extra we can get from the market. And later we switch our focus on the PGPI. It's because they can get more varieties, and we can isolate by ourselves. Okay, and not right now we got many bacteria strain. They work on different kind of crop. And give you a very simple example is most of the crop we test, we use like pak choy, the vegetable, or we test tomato plant. And they're all similar, like you use the bacteria strain, which show very strong antibiotic activity. Usually they will promote growth and also abiotic stress. However, when we try those bacteria strain in coffee plant, it doesn't work. It doesn't work at all, okay? And later we use bacteria strain which produce a lot of IAA. They produce, usually bacteria strain they don't produce too much of IAA, okay? And later we isolate one bacteria strain produce very high amount of IAA. And it does very well in coffee plant, okay? So you have to test, because I never test melon plant. But if you guys interested, maybe you can make some design or isolate your own bacteria strain, and you have to test it by yourself, because different plant, they have different kind of physiology response. So usually, like a tomato and for like a veggie, the bacteria strain, if you can show very good antifungal activity or that's our lytic, and now you can produce that activity, and that will work for those tomato plant. For melon, we try cucumber, but it's not melon, okay? But it's the same family. Cucumber, we try some like Bacillus licheniformis, it work. But I cannot say it also work for melon plant. I never tried melon plant. And in Taiwan, melon plant usually is grow in the greenhouse. And we grow in like a hydroponic system. That's why we never try use the bacteria in a melon plant in Taiwan, because they have a spatial culture system, okay?
Okay, maybe we can use trial and error for the PGPR. Maybe Bacillus, Pseudomonas, the strains. Maybe because in Taiwan and Indonesia we have a different season, we have different climate condition, so we need to find the right maybe PGPR, yeah, such as Bacillus, Pseudomonas, or maybe the other strains. We still need to do the trial error for the specific plants. Maybe next for the research idea from Agus. Okay, thank you. So for another participants, if you have any questions, maybe, okay, please, for the lady.
Okay, thank you for the time. My name is Ninyoman Ayu Praptirahayu. I am from Udayana University. So first of all, I want to say thank you for Prof. Didi, Prof. Yamamoto, and also Prof. Chuang for the precious presentation. For right now, let me ask questions, especially for Prof. Didi about organic farming. And my question is it organic farming in Indonesia truly a path to sustainability, or it is just a simply niche market catering to the urban elite? Because we together know that in Indonesia, our traditional farmers are always facing so many obstacles, like the access of the organic farms facility, and even though that we know the price of organic product or organic farming product is higher than unorganic farming product, but the input of the organic farming are also more expensive than unorganic farming, and not all of our farmers can capable to adopt organic farming in Indonesia. So maybe Prof. Didi, you can give an opinion about that question. Thank you. That's for my question.
Okay, to Prof. Didi, do you want to answer directly? Right. Okay, so maybe the challenging of the organic farming, because the implementation, especially of the farmers, the input may be more expensive considered rather than the conventional method. So what is the best strategy, or what is your opinion about that? Okay, please, Professor Didi.
Okay, thank you very much for the question. Is very great. Yeah, I think that's a lot of questions like that. Organic farming is more expensive than unorganic farming. That's right. The statement is right. Because when we use organic farming, actually the idea is not, number one, it's not the production itself, but how to maintain our environment, our soil, our land, our atmosphere better, right? That's number one. Second is the economical force, yeah. When we use organic matter, actually contain complete element, nitrogen, phosphorus, many things there, but the level is very low. For example, nitrogen, let's say only 2%, for example. When we use urea, 46%, mean that we apply, number one is of course the organic matter expensive than unorganic. And then to have or to guarantee that our product is organic, we should have certification. The certification is not very cheap as well. So that's why organic farming has red carpet, yeah, premium price. For example, in Indonesia now, for example, a rice, an organic rice, 1 kilogram about 15,000 rupiah, yeah, about $1. But organic one, 1 kilogram is between 50 to 75, between 3 to 5-fold of unorganic product. But so what is called, what we should do to encourage farmer is to be patient, because when we use organic, you know, let's say for example, if do experiment, I always do experiment comparing organic and unorganic together. How much organic can be subsidized to the unorganic one? From that thing we can see that in the short time, we get product of inorganic farming better than unorganic farming. You see, for example, in the first time when we did experiment, for example, inorganic here, organic here, but this one getting down, this one getting up. Why? Because, you know, when we apply intensive agriculture, we use artificial chemical substances that will impact, especially for the physical condition of soil. Later on to the biological thing, right? Even oppositely, that in organic farming, chemical fertilizer, for example, provide more nutrient, right? But when use the organic matter, actually, yeah, number one is it's ameliorant, you know, may improve the condition of the soil. That's what I can say, because that's really opposite. But both of things, we need it. We cannot say 100 organic, 100 unorganic, right? Because we need quantity. In organic, they produce 70% than organic farming. That quantity. But quality, yeah, organic product is, yeah, it's believed. Just check it. I mean, when we analyze this chemically, residue, whatever, so that why Prof. Agus asked me, what is the strategy? Use some organic thing in organic farming is not contain the pollutant I mean. In China, the problem in the paddy field is contain a lot of heavy metal, PP and Cu. And then they use phytoremediation. They plant like some grasses or something like that. The idea to absorb the heavy metal itself. So be careful when we apply organic material. Is that okay? Is that answer? Okay, thank you very much.
Okay, thank you very much for Miss Ni Nyoman. Okay, from Bali, yeah. So you fly directly from Bali to Semarang. Okay, thank you very much. Okay, actually there are still many questions must be from all of you, but the time is up. So maybe I want to ask the last statement from each professor. So maybe do you have any last statement for all participants before we close this session? Maybe from Professor Chuang first? No? Or Professor Yamamoto? Enough? Or Prof. Didi, is it enough?
Well, as my what is called it theme of the presentation is why should organic farming implement it? That's very important. Clean planet is our responsibility. Japanese, Taiwanese, Indonesia, Thailand, Malaysia, and so on. That's our responsibility. When we implemented organic farming as far as we can, mean that we maintain the cleanness of our planet. Just giving opportunity to survive of the soil and so on. So we guarantee to get sustainable agriculture. If our agriculture not sustained, then what we can eat? Health product, something like that. That's all from me. Thank you very much.
Okay, so please give applause to our amazing speakers for this first session. So if you still have questions, tomorrow we will have a lecture from our keynote speaker at Faculty of Animal and Agricultural Sciences tomorrow. So if you still have any question or you still want to discuss, you can join us at our lecture, right, Boji? Okay, so this is the end of our first session. So we will move to the second session with the other moderator after this. So thank you very much to Professor Didi, to Professor Yamamoto and Professor Chuang. So this is the end of the first session. Thank you very much, and we will see you on the next occasion. Good morning.
Ladies and gentlemen, it is our pleasure to express our sincere appreciation to our speakers who have generously shared their valuable insight with us. We would like to invite our speakers to stay on the stage. To Professor Didi Wisnuwijayanto, Professor Yoshinori, and Professor Wiwen Chuang. Please come to the stage.
As a token of gratitude, we would like to invite the chairman, Mr. Albertus Fajar Irawan, to present the appreciation to our speakers.
Okay, first, the appreciation will be presented by the chairman to Professor Didi Wisnuwijayanto, PhD. Next, to Professor Wiwen Chuang. Okay, next to Professor Wee Wen Chuang. And finally, to Professor Yoshinori Yamamoto, PhD.
Now, let us invite our speakers, chairman for a group photo session.
Thank you. Please give them a big round of applause. We will now proceed to the second plenary session, which will be moderated by Mr. Anasrullah, Master of Science.
He is a lecturer from the Agro-Ecotechnology Study Program, holding a bachelor degree in soil science from 11 Maret University and a Master of Science in Tropical Agriculture from Kasetsart University, with expertise in plants and soil nutrition. Ladies and gentlemen, please welcome Mr. Anasrullah.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Thank you, Master Ceremony, for welcoming me. So, in this second session of the plenary, we will invite Dr. Patavipa Songkuman and Dr. Nik Norasma to the stage. Please. Okay, Dr. Patavipa will present on the combating fungal disease in rice in Thailand, insight into pathogen diversity and host defense response, while Dr. Norasma will present on digital transformation in paddy management, the role of mobile technology in precision agriculture. Okay, while waiting the CV to introduce both of our distinguished speaker, so Dr. Patavipa, how are you today?
Thank you so much. It's kind of like my great honor to be here. Yeah, and it is really exciting. I mean, this is the first time for me here, Semarang.
Okay, so this is the first time for Dr. Patavipa to visit Semarang. And Dr. Nik Norasma, how are you today?
Alhamdulillah, thank you so much for the invitations. I also very excited to be here, and hopefully we can learn something from each other, inshallah.
Okay, so first we start with a profile from Dr. Patavipa Songkuman. Dr. Patavipa Songkuman is assistant professor on Department of Plant Pathology, Faculty of Agriculture, Kasetsart University. And his education, she start her bachelor in Prince of Songkla University, Thailand, and she finished her master in Kasetsart University and her PhD in plant pathology at Ohio State University. And her research focus on molecular plant-fungal interaction, plant-fungal diversity, and plant-fungal disease diagnosis and management. Okay, I think we can start now for the presentation. Okay, Dr. Patavipa, time is yours.
I decided to be there. Okay.
Yeah, it's
okay,
fine.
right?
It's fine, yeah.
Because I can see everybody. Yep. It's okay. Okay, good. So it's been that we cannot do by ourselves, right? So they're gonna do that for us, or? Oh, okay. Oh, okay. It's too far. Let me move here. Okay. Okay, great. Probably I have to go back here. Good morning, everyone. It is my great honor for me to be here at ICAS 2025. And I would like to take this opportunity to sincerely thank for the conference committee for giving me this chance, okay? And today for my topic is about combating fungal disease of rice in Thailand, insight into pathogen diversity and host defense response. And actually, Thai depend on the rice because it is the main staple food of Thai people. But also it is the economical backbone of the country as well. Unfortunately, it's faced with many multiple of threats, including biotic threat and abiotic threat. And if focus on the disease, I show you here in the picture on your right-hand side, you will see that if we see the statistic across 3 years, rice blood disease is constantly be the top rank compared with other disease in Thailand. And for those of you who may not get familiar with the rice plant with this disease, I would like to introduce briefly about this disease. Rice blood disease is caused by the fungus. The name of this fungus is Plenary or rice. Actually, it's gonna cause the yield loss about 10 to 30% annually worldwide. This disease can infect almost every part of the plant, as well as every stage of the rice development. And usually plant pathologists or the farmer will get familiar with the disease on the leaf because that leaf blast. And also the neck, we call that neck blast. In Thailand, usually farmers rely mainly on fungicide for controlling this disease. Using rice-resistant cultivar is the most sustainable method to control this disease, but it comes with challenge. The first challenge is in the plant side. In Thailand, usually we love to eat, we love to cultivate the cultivar named KDML 105 due to high market demand and the quality of cooking, eating as well. Unfortunately, KDML 105 is susceptible to many diseases, including rice blast disease as well. And we also have the rice cultivar named Chao Hom Nin. This is pretty good one, but it is the black rice. Okay, Chao Hom Nin is really have the resistance against several isolate of the rice bars across the country, and also have well resistant to the isolate from other country as well. So usually Chao Hom Nin used as the source of resistance against blood disease in Thailand for more than a decade. Okay, and right now Chao Hom Nin have been study to identify the rice blood resistant gene, and we found that they have a lot of rice blood resistant gene in Chao Hom Nin. In Thailand, usually we use P, I, K, the star, the red star. That is the main resource that we the main gene that we introduce in the breeding program in Thailand for 15 or 20 years right now. Another challenge is in the pathogen side. This fungus is very diverse in terms of their genetic diversity, and also this fungus is rapidly evolved, especially the genes that name AVR gene or virulent genes. I will talk about this later. So our team, a small team, like we work together to combat with the disease, focusing on diverse range of the aspects. For example, we focus on the population, dissect fungal population, even study on the genetic diversity of the AVR gene. We also have the breeder guide in our team as well, and study on the dissect on the rice immunity against this rice blood disease. We start the project by collect a sample, isolate the peel, isolate of the fungus. And before I go to the deep detail, I would like to explain about this one. Rice and rice bud interaction follow the gene for gene concept. So what does it mean? It means that when rice resistant to pathogen, it depends on resistant gene that can recognize AVR gene from pathogen. It's still very difficult to understand, right? I would like to show you the little picture on your left-hand side. Let's say when the fungus landing, the spore of the fungus landing on the leaf surface, what is that goal? The goal is that fungus would like to infect and then infect and growth inside the plant, right? That is the pathogen goal. Try to invade the plant, okay? So to invade the plant, this fungus secrete a lot of protein to facilitate their phagocytism, okay? And usually we call this protein with the neutron term as the effector protein, okay? For the rice, in terms of the rice, to defend themselves from this fungus, the rice going to have the protein try to recognize that effector protein. If this protein, we call that resistant protein. Okay, the resistant resistant protein, if it can recognize the effector protein from the fungus, it will elicit immune response, restrict the growth of the fungus. So right now, the effector protein, which is a general term, okay, the fungus secrete in order to infect the rice. Right now, it has been detected. So we're gonna change the way to call this one as a virulent protein. Okay, so when we know about the gene for gene concept, okay, if we do have the right cultivar, which is we know exactly what the resistant gene is, it means that we can identify the AVR gene in the rice pathogen. Okay, and this is fortunately for us. Right now, rice resistant genes, about 122 genes have been identified. 39 genes have been cloned and characterized. What does it mean? We know the sequence. And because of this one, they had a researcher develop the near isogenic line that carrying individual resistant gene. Okay, and even like lucky for us that Erie at the Philippines have this near isogenic line with different gene. So we request for this resource used in our experiment. What we have to do, just simply go in the field, sampling the sample, which show the right bud disease isolate for the peel isolate, single spore isolation. And then we use isolate to inoculate into the plant near isogenic line individually, and just like score, okay, the disease, the outcome. When we score that, they have the way to score the disease, so many, at least like from Ely itself also have one, and we follow from Bruman method. Okay, they're gonna give the scale from 0 to 6 scale. If you see the symptoms scale from 0 to 2, what does it mean? We're gonna interpret as the resistant, and if we saw the score like 5 or 6, we're gonna score that susceptible. With this one, we could identify. We found that most of the rice bud isolate in Thailand carrying AVR PIKP. Okay, and also the next high frequency one gonna be AVR PI20, AVR PI9, AVR PIK with another allele, AVR PIKM, and AVR PETA. Okay. And right now, until now, 12 AVR genes have been cloned. So it means that we know the sequence. So our group decided to explore the genetic diversity of the AVR that have sequence available, which is we were able to explore AVR PI9, AVR PIK, and AVR PETA. Okay. So what about the result? On the AVR PIK, we test only 60 isolate. We found that from 60 isolate, we could obtain the PCR product about 57 isolate. Okay, we take a look on this 57 isolate. We can classify into 3 haplotypes. I have to say that before this study, the haplotype of AVR PIK have been already available. from AVR PIKA until AVR PIKD. Our results show that most of the isolate that were found in Thailand, majority of them fall in the AVR PIKD group. Okay, they have also AVR PIKA, but with the less ratio. Interestingly, we could identify the new haplotype, which is AVR PIKF. This is a new one. Okay, usually when the isolate carrying AVR PIKF, you will also see that they're carrying AVR PIKD, so this reflect on the gene duplication for their adaptation, for their evolution. Okay, since right now we have the new haplotype AVR PIKF, we kind of worry about the result. So we start to test that whether the rice that carrying the PIK gene, every allele of PIK gene, which are available in the neoisogenic line. We have 7 allele of every IPA gene together. We test with this haplotype. We found that AVR, the isolate that carrying AVR PIK F can defeat all of every gene, every allele of PIK. So it means that right now Thailand usually rely on PIK as the main source for resistance against blast. Right now we have to think about try to find the new one, okay? Because right now we have the aggressive haplotype. Okay. In the case of AVR PITA, we could identify 23 isolate that could obtain the PCR product. And when we classify the haplotype, we could find 6 haplotype together. This reflect to their genetic high genetic diversity. We took a look on different parameter, especially Ka to Ks ratio, and the value was 0.366, which is less than 1. What that is mean here, when we interpret this result, it means that PITA1 gene was under purifying selection pressure. So breeder have to think about do we want to use this PITA1 because pathogen seem to be has a evolution against the AVR PITA1. Okay. For AVR PI9, we found that mode of isolate, on of isolate, we could obtain the PCR product. And we could classify into 3 haplotypes. Majority of the Thai rice bud isolate cling to one particular haplotype. Okay, and 2 for in another haplotype which is really similar to the isolate from Japan. Okay, and we found 1 isolate that fall into new haplotype. Okay, we worry again when we see the new haplotype. We check with the rice carrying PI9. Luckily, it's still PI9 still can defend themselves with this new haplotype. Okay, so the Ka and Ks ratio is about 0.9. So it means that AVR PIK is kind of like neutrality in the under the selection pressure. So that is good. PI9 should be the potential source for the breeding program. Okay. Our team also like development the KDML105 by integrate this PI9 using the crossback system. Okay. since I have only 5 minutes, I will like go a little bit fast, okay? We also study on the different response, try to identify the key genes that play a role in the resistant reaction regulated by this PIK and PI9 in order to use it as the, the key gene marker for future study on the molecular plant microbe interaction with this PIK and PI9. Okay, so similarly for the BAS research, so right now our team study on the fungal populations and identify that AVR, PIKM is the most frequently one together with other AVR such as PI9, PITA, and we do the genetic analysis and we found that AVR PI9 is good, it's not under the selective pressure. And this one we send this message to the rice breeder to develop the rice resistant with PI9 for the potential sort of resistance in the future. And we also like a little bit the information on the key gene, okay, for study on the rice blast molecule in molecular level in the future. We also study on the minor disease as well with the blood spot disease caused by bipolar oryzae, and the another disease is just like a tiny spot symptom on the rice, okay? And we found that again, just like collect the sample, isolate the pathogen, and study on their genetic diversity. In terms of the morphology, it's kind of diverse, okay? In terms of genetic diverse, in terms of the haplotype, we found 3 haplotypes, okay? But we couldn't correlate between haplotype and their aggressiveness, okay? And we also take a look on another pathogen, minor pathogen one, which is not no information available in Thailand. Okay, that is Exolohilum brostatum. We do the same thing, study on the divert in the morphology. We found that they are very diverse in morphological feature, and also the haplotype we classify into 4 haplotypes. Okay. Interestingly, we found that Exolohilum rostatum kind of like more aggressive if like we inoculate and put under the high temperature. Okay. And we found something similar when we take a look on the response of the rice cultivar against these 2 pathogens. We found that they show some similar result, which is they have one variety, which is the Jiao Hom Nin show the most resistant cultivar against these 2 diseases. And when we characterize the gene expression by focusing on the gene, the key regulator of the each hormone pathway, because hormone signaling also involved with the resistance in rice. We found that the result also very similar in which that salicylic acid, suspended acid, and ethylene defense signaling may not involve with the resistance. Okay. And vividly, they have the research that report that abscisic acid signaling may involve with the resistance in against bipolar oryzae. So in terms of Exolohilum rostatum, we also do the same thing. We treat abscisic acid before we inoculate. Okay, 3 days later, we inoculate the fungus, and we found that the treatment with abscisic acid show less symptom. Okay. So right now, in summary for the minor project, minor disease of the rice right now, we found that currently haplotype identified based on the local which may not link with the aggressiveness or pathogenicity. So in the future, we may focus on more, try to identify the key pathogenicity gene, okay? And for the right different response as well, in the future, we should do the experiment in parallel to try to identify the key genes that regulate resistance to this both fungus, okay? For the resource outlook, okay, so right now, currently we focus more on resistant interaction. In the future, we're gonna focus more on, increase focus more on the susceptible reaction as well. For example, try to identify the effector protein, even try to identify the targeting of that effector, and we also gonna move to study the climate change impact the rice pathogen dynamic as well. And thank you for the all of the funding agency and our team, and thank you so much. Okay.
Okay, thank you so much, Dr. Fatah Viva Songkuman, for the excellent presentation about rice blast disease and its molecular diversification, and then try to breed the rice-resistant varieties from the blast disease. And next, I would like to introduce you to the next speaker, Dr. Norasma. Okay, so Dr. Norasma is a lecturer from the Department of Agriculture Technology, University Putra, Malaysia. Her research focus is on the GIS, Global Geographic Information System, as well as the precision agriculture and hyperspectral imaging. And his current project is trying to use hyperspectral imaging and machine learning to detect weed in the rice cultivation. Her PhD is from the Queensland University, and in this afternoon, she will present mostly on the precision agriculture and on how we can apply or how we can use precision agriculture in paddy field. Okay, for Dr. Norasma, time is yours.
Thank you, Mas Anas. Assalamualaikum warahmatullahi wabarakatuh, and very good morning, everyone. My name is Nino Rasma. I am from University Putra, Malaysia, UPM, and I am from Department of Agriculture Technology, Faculty of Agriculture. So today I would like to share my experience with my students, and also a little bit about our research previously, so that maybe in the future, if you want to do some collaborations with UPM, we can talk further after this. So I would like to introduce rice in Malaysia, as we heard a lot of information about rice today. So in Malaysia, we also have a problem in terms of self-sufficient ratio, which is we are still imported some of the portion, about 30% from the neighbor country. And then there's a lot of factors why we didn't have enough productivity for our populations, because of the climate change, you know, and also the weeds, pests and disease, and a lot of factors actually. Okay, so hopefully by using the precision agriculture technology, we can improve the productivity and management, so that we can increase the productivity, so that we can reduce or we can minimize the depending from the neighbor country rice. Oops. Next. Tak gerak. Okay. I think it is too. Sorry. So as you see, Malaysia also have issues about the productivity, every year we have some a little bit decreasing about the production of rice, okay, and we are actually try to improve the productivity year by year, okay, and hopefully we can reduce the import rice, okay, from the neighbor country. So how we can improve the productivity? We can actually try to use the technology, for example, the digital agriculture, because it can help in terms of management and also the operation system. So normally for the digital agriculture, we use a lot of technology, for example, AI, robotic, mobile apps, drones, okay? So it can help in terms of optimizing the input and also reduce the effect from the chemical usage, and also we can increase the yield. So basically, if you see from this figure, we can use a lot of technology, okay, in smart farming. And for the data acquisition, we can use the remote sensing and GIS, okay, for the monitoring the base map first, and then from the base map we can do the analysis, and then we can know how much the input that we can apply to the field, and we can reduce the cost, okay, and also we can actually monitor the crop, okay, by using the mobile apps. And when we apply the optimum input, okay, we actually can maximize the productivity. The problem in terms of production is actually the farmers sometimes didn't put the right input in the plantation, and it will result the low productivity. So when we actually calculate how much the input the needed for the plants or plantations, we can actually improve the productivity or the yield. So I have a video here. Can you play this video? This is another research with my master students. We developed the mobile apps for farmers in Kedah, Kelantan, Malaysia, to help in terms of monitoring their rice field. I will explain later about the project. So we move to the precision agriculture. So precision agriculture is actually a method, okay, that can actually measure the current content of the soil or condition of the crops, and then we need to do the calculation how much we want to apply the input. For example, the fertilizer, or if we want to detect the weed and how much the herbicide that we want to apply to the particular area. So how to get the calculation, we need to use the spatial variability or the tools like remote sensing and GIS, and also drone, okay, to identify the condition of the field. So by combination of the IT, we can actually combine all the information in one database and save all the information in the mobile apps later on, and the farmers or the officers can monitor their field by using the smartphone. Okay, so basically in remote sensing, we have a lot of platform or integration between a lot of technology, for example, drone, okay, and GIS for the image classification, software imagery, satellite and analysis. So all this platform is actually integrated, and we can come up with the output, how much the fertilizer, for example, or how much the condition of the crop we need to apply the input, okay. So remote sensing basically is a tools, okay, to do the prediction or interpretation of the area, okay, without we going to the particular area. We can do by far. For example, we just fly the drone, or we can just use the satellite, and then we can come up with the map. But to classify, to validation the area, we need to do some ground truthing, and we need to cross-check to the ground so that the classification is valid, okay? So basically, remote sensing or drone use the passive sensor that we need to use the energy from the sun, okay? So basically, the plants will observe all the lights, and then will reflect the near infrared and green. That's the reason why we can see plants in a green color, because from the reflectance of the green, okay? But as a human, we have a limitation, and we cannot see the near infrared light, okay? So human only can see the visible range, visible color, RGB. So that's the reason why we can see green color, because plants is actually reflect more on green, but it's actually reflect more on near infrared, which is without our naked eyes, we cannot see the near infrared, but we can see from the sensor. So that's the reason why we use the hyperspectral or multispectral to monitor the condition of the plants, okay? So basically, for the data acquisition, we have a lot of platform. So in my research, I always focusing on the UAV or drone, okay? But satellite imagery also is quite important if your data or plantation is very huge or big scale. So satellite is the best, okay? So you need to understand what you want to achieve and what is the scale for your plantation, so that you can know which sensor is suitable for your mapping. So this is the advantage where you use the drone or the satellite, and all the platform there is have advantage and disadvantage that you need to know what is your purpose for your project, okay? So basically in drone or UAV, there is a two main category for mapping and also for spraying, okay? So basically, what we do, we always do a mapping first for scan the area, and then we can spray based on the mapping, okay? So that we can reduce the input, because when we have the map, for example, we know the location of the map, the weed map, so we can fly the drone to the weed patches instead of we just fly the blanket application. So it can reduce the input, and also at the same time can protect the environment. So this is the example for the precision agriculture by using sensor, okay? We can use RGB, multispectral or hyperspectral for many applications. So to do this, we need to make sure we have or we choose the right sensor, because not all the application we can identify using RGB, but we have to see from the literature which sensor is suitable for the particular application. So basically, when we fly the drone, we need to know the altitude of the drone. Okay, so the lower you fly, the high resolution you will get. Okay, so that's the reason why we move to the drone, because it can give you very high resolutions, and you can detect, or you can do the analysis up to the species scale. Okay, and this is the advantage and the difference between the sensor. Each sensor have their own applications, okay? And it doesn't matter if you want to use the hyperspectral or RGB, but you have to understand first why you need to use that sensor, because the expensive sensor sometimes is more complicated compared to the RGB sensor, okay? So this is the multispectral sensor that actually have a different application for each band. Okay, so that's the reason why we have an advantage if you use the near infrared, because it can monitor the plant stress, and we can indicate the condition of the plants. So you can see here, this is the spectral signature of plants. You can see the difference between healthy and stress leaf. So if the stress leaf, it will reflect lower compared to the healthy leaves. So this is the tricky, because our eyes only can see from visible. So near infrared here, we can see from the graph or sensor. So this is how we actually play around with the object or the species plants, the condition of the plants. And each object is actually have a different spectral signature that you can actually identify which species or what object for the spectral signature. So this is the vegetation index that quite common use for the agriculture, and you can see to run this algorithm, you need to have a suitable sensor, okay? And normally, this is the common algorithm for the compare between non-vegetation and vegetation. We call as normalized different vegetation index. So high NDVI is indicate the healthy vegetations, okay? And lower NDVI indicate is a stress, because when we see from the stress leaf, the near infrared not reflect higher compared to the healthy leaves, okay? But the NDVI is actually algorithm to compare between vegetation and non-vegetation. You cannot easily, based on the value, to indicate this is healthy, because the range is actually is varied, and you have to check to the ground as well. Sometimes, based on my experience, the highest NDVI is actually indicate for the wheat, because the wheat is quite survival plants, and rice plants is a little bit lower. So we have to always check to the ground. So this is the example that we fly the drone in paddy fields, and then we check at the ground data, and when we run the analysis, we always do the correlation between the ground and the area, so that we can come up with the crop growth map or yield prediction and so on. So this is another, can you play the video? Can you play the video? So this is one of our drone from the DJI Inspire 2. So this drone is actually originally carry the GoPro camera, RGB camera. But then we actually custom made. We put the GPS on the top of the drone, and also we change the payload. Okay, so the payload here is actually from the RGB, but we want to run the multispectral. Okay, multispectral we can buy separately, whether you want to buy with drone or you want to buy only with the sensor. So what we did, we actually buy the sensor from Mika Sense, Parrot Sequoia, and then we put under the drone, And since the sensor is separated, we need to make sure the sensor have the GPS. So that's why we put the GPS on the top of the drone, okay? And then we need to connect to the mobile smartphone to the remote control to do the waypoint. So normally drone, we actually fly the autonomous way, and then when we fix the waypoint, the drone will fly autonomous and come back automatically. So if you can see here, this is the original payload, RGB GoPro camera from Inspire 2, but then we actually changed. So before that, we have to do the calibration, okay? So normally, the compass calibration we have to do if we want to change the location. For example, I already fly in UPM, and then I want to go to Kelantan, which is quite far from UPM. So the apps or the drone will give the notification. We need to do the calibration compass. Okay, so this is how we do the calibration compass. The notification in the apps here, we give you the instruction, okay, to do the calibration. So this is really important. When you want to do a multispectral or hyperspectral, you have to do the calibration before and after you fly, so that your data is less noise and also accurate, okay? So after we do the calibration compass, then we can change the payload here to the Mika Sense, okay? So the apps is actually free. You can download from your smartphone, but you need to have a drone lah, okay, to connect or to operate the drone, okay? And then it changed the payload here, okay, to the multispectral, okay? But now I really recommend, if you want to use the multispectral drone, you can buy from the DJI. Is 1 minute. 1 minute, okay. Okay, I think I can skip this one, okay. So I want to go to the mobile apps. So you can see when we have all the data, okay, the drone, the data sets, okay, we can actually put all the data in the smartphone, and then users can easily monitor, okay, the crop, the plantation, and so on. So this is my previous research. We also developed the web GIS, okay, and also with my master student, mobile apps that I show you the video just now. So we combine all the drone data in one apps. So every season, farmers can see their yield, okay, and then it can give some recommendation what to do for the next seasons. And also another research, we also, when we have the hyperspectral, we put all the hyperspectral in spectral library in the one mobile apps. So each weeds and rice and pest and disease have their own hyperspectral signature for each object. Okay, so this is another project with mobile apps as well, but for the mata identification. So when users capture the seedling of mata, they know whether it's pure or not, okay? And this is another project for drone, okay, since I need to go very far. I think, so basically, the hyperspectral drone here, we do to detect the weed because, as you know, weed is really hard to identify in the paddy field. So when we use the hyperspectral, it can actually differentiate, especially for the weedy rice and rice, okay? And we can see the spectral signature have a different spectral signature, and from that we can run machine learning to identify the species, okay? So we run in the field and also in the glass house in UPM. So for the benefits of mobile apps and smart agriculture, we can increase the yield, reduce the cost, and also detect the weeds and pests and disease. But the challenging is always when use the technology, we have to, depending on the skill of the people, the environment, okay, and
to do the processing. Okay, so we have to study. Even our team, we do a lot of try and error to get a very good results. Okay, so for the future direction, we can actually do some integration between the AI, smart farming, and also with the farmers. Actually, they actually know more, okay, about the agriculture. So as a conclusion, so we can actually do the integration between the digital technologies, okay, and also adopt these tools to enhance the productivity and also encourage to use the digital innovations to shift from the traditional to the modern agriculture. So this is my students, and I would like to thank you to the University of Diponegoro, okay, for inviting me, and hopefully we can do more collaboration in the future. Thank you so much. Thank you.
Thank you so much, Dr. Norasma. So, I think it's time for the discussion because the time is quite limited for this afternoon. So, first, I think I would like to open a discussion session and maybe one or two questions first from the room. Anyone would like to ask question, please raise your hand. Or maybe it's, oh, okay. Please.
Okay, thank you for the time. So thank you for Dr. Nick for the amazing presentation. Yeah, and I have 3 questions for you, Dr. Nick. The first question is, what kind of programs that include in Paddy to you? And then the second question is, who will be upload the data in Paddy to you? Is it the farmer or agricultural extension? Yeah. And then the last one is, who is the user of Paddy to you? Yeah, okay, so that is the question for me. Thank you for your kind attention.
Yeah, sure, you can answer directly.
Thank you so much for your questions. So the first one, what is the program? We use the AMD Master software, okay, to develop the apps, and we have to pay yearly for the server, and then we can develop based on the software AMD Masters. If you want to know, I can share little bit details after this. And who will upload the Paddy to you? Basically, is a officer because we collaborate with the agency agriculture in local area, which is called KADA, specifically for rice farming. The officer there we upload, but with helping with our student, we actually do a transfer of technology so that they can understand how to upload and maintain the database and apps. And user is actually, we have 2 users, farmers and also for the officer. Because farmers, they actually can see their lot number and also the yield for every seasons. The officer can actually monitor for all the farmers' activities, why this plot is higher compared to other plots. So that's how it works. Thank you.
Okay, thank you, Dr. Nick. I'm sorry, I forgot to introduce myself.
Okay,
yeah,
sure.
My name is Klasia. I am from Udayana University. Yeah.
Okay,
Nice
thank
to meet you,
Nice
Doctor
to meet
and
you.
Prof. Yeah.
Okay, is there any other question from the room? Or maybe is there any question from the chat box in Zoom or YouTube? Okay, Dr. Norasma and Dr. Patavipa, so learning the plant and fungal relationship and also the GIS and hyperspectral modeling, it's quite, can be combined into how can we detect the pest disease in rice with the drone. I think that's quite interesting. And maybe in the near future, we can do a collaboration, I think, right? And how to control the blast disease in rice and how to manage it with a drone as a sensor to observe how severe the disease impacted the rice. Okay, is there any other question maybe from the participant? Okay, sure.
Thank you very much, moderator. I would like to ask to Dr. Patavipa, about the blast disease. So if we want to create new rice variety that might tolerable to blast disease, how is the possibility that the fungus by blast also evolve with the rice variety? So is there any possibility that the evolutions of the fungus also occur in the future? How we compete with this issue about this? Do you understand?
Do you get it? Okay, so Mr. Fajar question is more likely on when we develop a new variety of rice which is more resistant to the blast disease, and what possibility that the disease itself is evolving together with the new variety of the rice.
So it means that how to like reduce that potential of the fungus to evolve the new one, right? And actually, they have so many things that we can do with that. For example, rather than like breeding for individual R genes, so you can pyramiding by putting different R genes, so it kind of reduce the selective pressure as well. Or as our group did that, right? Instead of like breeding, used only one PI, 9 allele, we use different allele as well. So this is gonna be slow down the evolution of the rice blast. Okay, this is gonna be that's why we do not focus only like breeding individual gene. We also like try to pyramiding or create like our own isogenic line, KDML 105, the most popular one in Thailand, and put different resistant gene, okay, and just like make sure that it still maintain the high quality background that we would love to have it, okay, by screening method, okay.
Okay, maybe I have one more question, Achan, regarding to the blast disease in rice. So currently, most farmers trying to control it by fungicide, as you mentioned earlier. But the problem is, they want to have like instant results. So, what do you think that instant results, like they are controlling it with fungicide, because they want it to clear directly, and how about in the next 5 or 10 years? Do you think that the disease will be more severe, and how, as a researcher, like a researcher and a farmer, we can like educate ourselves on how to control the blast disease, since the disease itself is still evolving, and the farmer always want to make it quick, to clean it quick. Okay.
And actually, like I think because the perception of the used new variety actually is the same. KDML 105 is the same, but just different one gene just put inside. But but we cannot use very similar name in Thailand, like use KDML 105 plus something. We cannot use that. So that is like so that why the farmer do not accept to use that. Okay, so it's gonna be very challenged in terms of like try to motivate them to use the same rice cultivar KDM 105, but even more better by planting the resistant one. But I think the older farmer gonna be like, change to the new generation one with more educate, right? So, and I hope that through the those extension team try to encourage and put more some knowledge to them, like, okay, it is the same background, okay, and like promote to use it, okay.
Okay, thank you so much, Dr. Patavipa. And one last question for Dr. Norasma, I think, how can you introduce the apps to the farmer or to the practitioner for them to use it? Because not so many people, even the young people, the young farmer, want to use that kind of complicated apps. So how did you introduce it to the farmer or practitioner? And the second question is, how large the data so it can have a very good accuracy results? Is it like you need to collect data in 200 different regions or something like that, and how large is data so it can be accurate to predict anything that we want? Okay, thank you.
Okay, the first one, how normally we need to do a meeting first with the farmers, with help from the officer agency, like agriculture officers, and then we meet them in the field. Sometimes we put like a half-day workshop, okay, how to slowly introduce the technology or the apps, and then we do some follow-up, maybe after 2 months, every 2 months, get some feedback how they actually want to have in the apps, for example, and maybe get some comments from them, what we should put or what can improve the apps, okay. So that's how we actually do, and we get also some quick survey to get some comments and feedback from the farmers. And actually sometimes we also give some incentive, whoever active in the updating in the app, so that we can give their happy to use that, so that then when they feel like it's helpful, then we use it, okay. And the second one, can you repeat again?
So it's how big the data or how fast the data so the prediction can be accurate.
Okay, normally if you want to use drones, the area normally we not suggest for the big area, a small area. For example, like our pilot project is just very small, like 7 hectares. Okay, so if the small scale, we can get at least 1 to 2 days, we can produce the map directly, because the area is quite small and we can do the processing. So it depends of the area as well.
Okay, thank you so much, Dr. Norasma. And I think it's time to give a closing statement, I think, from Dr. Patavipa, 1 or 2 words for the participant, like for as a closing statement, and Dr. Norasma too, maybe.
So for me, like as a plant pathologist, I think that the role of the plant pathologist should like go to the field and then try to observe this kind of like interaction. So in order to get the information like in time to deal with the uncertain situation, especially during the climate change. So right now, our team also like get the funding and focus more on the climate change, because especially in the rice bud, we found that some resistant gene that lose their effectiveness in terms of the different response, or some resistant gene even do better during the high temperature, something like that. So this kind of information are still very limited, so we can like work more and focus more on this trend. Okay.
Thank you so much. So from me, I think the technology is very fast, okay? Even though we feel like farmers are quite difficult to understand the technology, but then I think time to time they will understand. And now I think a lot of farmers already have their own drone. They are started slowly to understand the technology, and I think we as a researcher need to give a guidelines to them so that they can use in a proper way, because it's just a tool, but then we need to understand as well about the data sets and the analysis. Okay, I think it's really a good start for the digital agriculture. Thank you.
Okay, thank you so much, Dr. Patavipa and Dr. Norasma. And for the conference audience that would like to learn more about the GIS and also the plant and fungal relationship, we have a guest lecture tomorrow in the Faculty of Animal and Agricultural Science at Universitas Diponegoro. You are very welcome to join our guest lecture. So if you have anything to discuss more or you want to see more on the presentation, please come to our faculty and join our guest lecture. I think that's all for us, and I will give back the time to the Master of Ceremony. Okay.
Thank you to our speakers and moderator.
Ladies and gentlemen, it's our pleasure to express our sincere appreciation to our speakers who have valuable insight with us. We would like to invite our speakers and moderator to stay on the stage.
As a token of gratitude, we would like to invite the chairman, Mr. Albertus Fajar Irawan, to present the appreciation to our speakers. First, the appreciation will be presented by the chairman to Assistant Professor Patavipa Songkumaran, PhD. Next, to Dr. Norasma Jaya.
Now, let us invite our speakers, chairman, and the moderator for a group photo session.
Okay, on my count, 1, 2, and 3. On my count, 1, 2, and 3. Noble, valuable. 1, 2, and 3.
Okay, please give them a big round of applause. Thank you very much. You may now return to your seat.
Ladies and gentlemen, That concludes the plenary sessions for today. We hope today's session will inspire fruitful collaboration among all participants.
On behalf of the committee, we would like to thank to our speakers and moderators for the valuable insights shared, and also thank all participants for your active attention. We will now have a break before continuing with the parallel session, which will take place from 1 p.m. to 5 p.m.
Please kindly check the room assignment provided, which can be seen in the program book as well on the notice posted on each door. After the break, you may directly proceed to your respective rooms. Thank you and enjoy your break.
Silakan untuk makan siang atau disediakan.